Okay, so I've got a different setup here now. You might not be able to see it. I don't want to move the camera too much. What I've got over here is a wooden retort stand. And wooden because, of course, most of the retort stands are steel. So if we want to demonstrate any magnetism, the steel will interfere with the magnetism. I've got a bit of red card. White card would have been better, but I couldn't find any. And then I've got a bit of copper wire running through the middle of the card. And what I'm going to try and do is put quite a large current through that bit of copper wire. There you go. You can, I don't know whether you can see on the screen there that I've got about 5.5, 6 amps running through the copper wire. If I try and squeeze any more out than that, I'm probably going to overload the power supply. You know they overload at 9, and it's only going to be a matter of touching it now and it'll overload. Now, what I want to try and show is that I've got a magnetic field. And I will be able to show that is another matter. I think on the video screen there that probably just looks like a mess. Let's see if I can get it so that it doesn't quite look so much like a mess. Now, even from there, you can't really see what I was aiming to produce, which was concentric circles. Yeah, if you squinted and pretended, you might be able to believe you were seeing concentric circles in the iron filings there, but I'm not convinced. So I'll have to have a different way of doing it. So these are my alternative. They are what are called plotting compasses, which are basically just very cheap magnetic compasses. And I hope you can see here that they're all roughly sort of pointing in the same direction. There's one or two, this one here for example, that are pointing in completely the opposite direction to all the rest, because it's north-south has obviously been swapped at some point by some horrid child bringing it too close to too strong a magnet. But essentially they're just little magnetised bits of metal that, as you move them around, should still point towards the Earth's North Pole, and they settle down and they end up pointing that way. So they're plotting compasses. And what I'm going to do is I'm going to place them around a wire. Or throw them on the floor, one or the other. There's a good reason why the plotting compasses don't work very well. They get thrown around. Now the trouble is, because they're magnets, as I've put them really close together, then what's now happening is they're all rather attracting each other, so they've sort of stopped pointing north, but nevertheless. Now, I've reconnected the wire. Now, I'll find an angle. Right, so at the moment, current's off. You can see the magnets, the plotting compasses here, sort of pointing at each other. And I turn the current on and put through 6 or 7 volts through that bit of copper wire that's poking through there. And did you see they all moved? Turn off again, and they moved back again. For some reason, that one didn't move. Don't know what's wrong with that one. So, try it again. You'll hear the power supply turn on. And you see them move. Turn it off. They go back to how they were before. Not quite as dramatic as it is sometimes, but not too bad. And what you might be able to see is that they are pointing round in circles. Maybe not that one out there, but most of the rest of them going round in a circle. I've done more convincing versions of this experiment. But, you know, they go, certainly those ones on the far side go back to pointing north. Now they go round to going round in a circle. Yeah. So even if you don't believe me about the circle, I hope you believe me that our bit of copper wire, copper is definitely not a magnetic material. When our bit of copper wire has no electrical current flowing through it, it has no influence on the plotting compasses. But when I have a current going through it, it does indeed have an influence on the plotting compasses. Magnetism is created by a flow of charge. And so my copper wire, not magnetic in any way, shape or form, but a good conductor of electricity, put a lot of electricity through it, and we get a magnetic field roundabout. Okay, last little demo I'm going to do in this set for you is to use the plotting compasses with a coil of wire. You see that that's a coil of wire. Now, the magnetic field you may have gathered from the last demonstration, the magnetic field around a single wire is not very impressive. So we need a way of increasing it if we want to make things called electromagnets. And the way we increase it is with a coil, with a helical coil, which is what I've got here. Now, normally such a thing is called a coil. When we are deliberately making a coil of wire in order to increase its magnetism, and we plan to use it as an electromagnet, it has a second, more technical name, which is a solenoid. So this is a solenoid. And what we've done by wrapping it around in this helical way is every bit of magnetic field due to each wire adds up. So each coil of wire here adds its own magnetic field, and all those magnetic fields add together, and we get a much stronger magnetic field for the same amount of current. So just a bit of wire produces a magnetic field, not a very strong one, but with a coil, we add together all the magnetic fields, and we start to produce very strong magnetic fields. And of course, all we have to do if we want to increase it further is add more coils, add more coils, add more coils. So my current is not turned on at the moment. You can see my plotting compasses are roughly pointing sort of over there somewhere. And if you watch it when I turn it on, hopefully it won't short out. There you go. What you should have is the ones running up the centre are all pointing straight line up the centre, and then it curves around, goes back up the centre, and then goes up the centre, curves around, goes back up the centre, curves around, back up the centre, up the centre, curves around, back up the centre. And it actually produces a magnetic field just like the magnetic field of a bar magnet. Except, of course, with the bar magnet, you can't normally see the magnetic field in the middle bit because there's a bar there. But the field around the outside, the field lines curving round, just like you get with a bar magnet. And so just like a bar magnet, a solenoid has a north and a south. We have a north end and a south end, and the magnetic field curves around from north to south, just in the way it did with my iron filings and the bar magnet right at the very beginning of these demonstrations. But of course, the advantage with the solenoid, I can turn it off, and if I add on more turns of wire or I increase the current, I can make it stronger. So electromagnet gives you a huge amount of control that you don't have with a permanent magnet.